Listen to the news by Forbes magazine. Shopify made AI use mandatory. Tobias Lutke, CEO of Shopify, said teams must prove they have used AI before asking for hiring a new employee. Jane Fraser, CEO of Citigroup, has placed AI at the heart of the bank's $12 billion modernization effort, focusing on both operational streamlining and better customer experiences. John Mueller, CEO of Procter & Gamble, said AI enables each of us to be more productive and more effective, to be better at our jobs. These are just some examples showing that AI is going to change everything, like what electricity did. To increase the awareness of Agilists, I have decided to create this quick start training, helping them lay down a robust basic understanding of AI. Through this training, I will elaborate on 6 main topics, serving Agilists to build their new mindset about AI. If you stay around until the end of the video, you will get a step-by-step practical example of using AI to create a compelling product vision video. So stay with me. Number 1, AI evolution over time. See this list. The list shows the amount of time each technology took to reach 100 million users worldwide. It is 75 years for the telephone, 4.5 years for Facebook, and just 2 months for ChatGPT. It's insane. AI is the fastest growing technology in human history. It's interesting to know that AI is not new. It has been a part of our lives for more than 70 years. What we are experiencing these days is a specific subset of AI called generative AI that we will talk about a bit later. Artificial intelligence, or AI, is a technology that enables computers to simulate human intelligence and problem-solving capabilities. Let me give you some examples. Speech recognition, where AI processes human speech into a written format. The example is Siri, which is available on all Apple devices. Computer vision, where AI derives meaningful information from images, videos, and other visual inputs. Imagine when you enter a parking lot, AI reads your car's plate number and issues your ticket. The idea of artificial intelligence began with Mr. Alan Turing, who in 1950 proposed the Turing test to evaluate whether a machine could show human-like intelligence. The Turing test is a simple way to check if a computer can think like a human. Imagine you are chatting online with someone, but you don't know if it is a person or a computer. If you can't tell the difference just by the conversation, the computer has passed the Turing test. There were no practical implementations or real-world experiments of the Turing test at the time. It was a theoretical proposal. It was a foundational idea that guided AI research for decades. A few years later, Mr. Arthur Samuel, an IBM engineer, built the checkers playing program as the first practical demonstration of machine learning. In 1956, the term artificial intelligence was officially coined at the Dartmouth Conference. This was the first formal proposal to explore whether machines could simulate human intelligence. 1956 is often seen as the birth year of AI as an academic field, kind of like when Agile started becoming a thing after the Agile Manifesto in 2001. AI has 3 main categories. Let's check them. First, ANI, or artificial narrow intelligence, which is used for a very specific purpose. For example, self-driving car, defect detection in a factory line, etc. Second, Gen AI, or generative artificial intelligence, which is used for a bit more general purposes by creating completely new content like ChatGPT, Google Gemini, etc. And third, AGI, or artificial general intelligence, which is the ultimate goal for AI to do anything that a human can do. We are not there yet, and it is far from now. This is the future of AI. Let's move on to the second topic, why and what of generative AI. Based on the definition, generative AI refers to artificial intelligence models that can create completely new content, such as text, images, audio, or video. Examples are ChatGPT or DeepSeek. Behind the scenes of every AI system, there is a model that has been trained on massive data to mimic patterns. So we need learning processes for AI models. It started with machine learning, which enables systems to learn from data, identify patterns, and make decisions or predictions. The evolution of machine learning led to the emergence of deep learning, a branch of machine learning that uses multi-layered neural networks to learn complex patterns among data and create highly accurate outputs like images. Don't panic. We don't want to deep dive into the technical aspect of AI. Just be aware that deep learning is the next improvement of machine learning. If you wanted to have a hierarchy for AI and its subdisciplines, you can see AI at the top, then machine learning comes next. Under it, you can see deep learning, and underneath level is generative AI. To compare AI and generative AI, you can think of AI as a chef who can cook dishes from an existing list, and generative AI as a chef who can invent and cook an entirely new dish. There is an important question here. Why are we experiencing generative AI at this time in history rather than in the past? The answer includes three reasons. First, the dramatic improvement in the power and capacity of hardware processors. Second, fortunately, with the advent of the internet, a huge amount of data has been converted to digital over the past 3 decades, which allows us to train AI models with enough data. And third, the emergence of much more effective and faster algorithms used to train AI models. As the last point, be aware that although we see amazing results from generative AI tools like ChatGPT, they don't understand what they are saying. They process data and create outputs based on probabilities, not genuine comprehension or awareness. While they can simulate understanding effectively, their answers are ultimately a product of pattern recognition, not true intelligence. They are like a parrot that has learned to mimic human speech. It can repeat phrases and even construct grammatically correct sentences, but it doesn't understand the meaning of what it says. Number 3, how AI models are built. For better understanding, I use a simple analogy. Imagine you want to open a restaurant business and serve people with pizza. To do so, you need 4 main steps to cook and serve pizza. Step 1, you need ingredients for pizza like its bread, cheese, mushrooms, sausage, onions, olives, tomato sauce, etc. In fact, they are all the raw materials you need to cook pizza. Step 2, recipe, your process and step-by-step instructions to cook pizza. Step 3, cooked pizza, which is the final product of applying the recipe to ingredients. And finally, step 4, restaurant, a place to get the customer's order and serve them with their desired pizza. Now, let's map it with the process of building AI models. Step 1, data, the ingredients that you use to train a model with. It can include various types of data like text, images, audio, etc. Step 2, algorithm, your recipe and instructions on how to process data and learn from it. There are a bunch of algorithms out there, like the transformer algorithm. They are evolving constantly. Step 3 model, like cooked pizza, the final product of the training process, like GPT-4, the model behind ChatGPT. Nowadays, you see a big competition among giant tech companies trying to train better and more powerful models. And finally, step 4 application, like a restaurant where users can communicate with the AI model and get their desired answer, output, or result, like ChatGPT. Generative AI is not magic. It's a system built step by step, trained on massive datasets, guided by algorithms, shaped into models, and deployed through applications. Now let's talk about the various learning processes that are used to train AI models. There are 3 main learning approaches: supervised learning, unsupervised learning, and reinforcement learning. Let's check them one by one. Supervised learning, learning with a teacher. This learning approach uses an input-output mapping mechanism. Let me give you an example. Imagine you have found this sentence on the internet and fed it to the algorithm. Russia is the largest country worldwide. The algorithm will break it down into input-output paired data points as follows. Input, Russia. What would be the next word as the output? Is. Then the next pair. Input, Russia is. The output would be the. Next pair, Russia is the. Output, largest. Next pair, Russia is the largest. Output, country. And the last pair, Russia is the largest country. Output, worldwide. These data points work like a teacher. When a user asks generative AI which country is the largest one worldwide, it leverages its learnings and starts generating the answer by predicting words one by one to create a complete sentence. Although a lot of factors and mathematics will be used to generate the optimum output, the fundamental process is the one that I explained. Another example is giving the model 100 photos of cats labeled cat and dogs labeled dog. The AI learns to map photos to the correct label. Now, if you give it a new photo of, for example, a dog, based on its learning, it can classify it as a dog. This process of supervised learning based on input-output mapping is being used a lot. Real-world examples are email spam filtering and language translation, for example, from English to German. Unsupervised learning, learning without a teacher. Now imagine you are given a big pile of data but no answers. No one tells you what's right or wrong. You just have to discover structure or patterns yourself. As an example, you are handed 100 songs with no info about their genre. You listen and start grouping them by similarity: upbeat versus mellow, pop versus jazz. In the AI model training process, the model finds clusters or patterns in the data without a labeled output. Real-world examples are customer segmentation in marketing, grouping similar news articles, and detecting unusual activity in credit card transactions, anomaly detection. Reinforcement learning, learning by trial and error. The model learns by interacting with an environment, receiving rewards or penalties for actions, and aims to maximize the cumulative reward, like game playing. As an example, you are learning to play a video game. No one gives you the answers, but every time you win, you get points. Every time you lose, you try a new strategy. Over time, you get better. Real-world examples are self-driving cars, game playing like chess, and dynamic pricing. We have talked about learning processes. Now, let's have a look at the main categories of AI models. Models can be categorized based on the content type that they generate. See these three famous categories of AI models. LLM, or large language model for text generation, a type of AI model trained on vast amounts of text data to understand and generate human-like language. For example, the GPT-4 model by the OpenAI company. It's like having a really knowledgeable friend who is always ready to help with words. The large word in large language model LLM refers to the vast size of the model in terms of the number of parameters in the training algorithm and the amount of training data it uses. The number of parameters is a key indicator of an AI model's scale and potential capability, but it's not the only factor. The quality of the training data and the model's architecture also play crucial roles in its overall effectiveness. The number of parameters can have a range of millions to even trillions. As an example, you have probably seen these phrases. The GPT-3 model has been trained with approximately 175 billion parameters, or Gemini 1.5 has been trained with approximately 200 billion parameters. Diffusion model for image generation, a type of AI model that learns by iteratively adding noise to data and then denoising it to create new images. For example, DALL-E model by the OpenAI company. GANs, or generative adversarial networks for video generation, a type of AI model that is widely used to generate videos. For example, the Runway model by the Runway AI company. Bear in mind that some models are multimodal, meaning they can process and generate multiple types of data like text, images, audio, and video. An example is Gemini 1.5 by Google that can process and generate text, images, audio, video, and even code. Number 4, AI cost and understanding tokens. Although most generative AI tools have a free plan to use, for business usage you have to pay. But how is your usage calculated? To do so, a unit is needed to calculate your usage. It is called token. A token is loosely either a word or a subpart of a word. A bit more detailed explanation is that tokens are the smallest individual units of a language model and can correspond to words, subwords, characters, or even bytes. In simple cases, one word equals one token. For example, hello equals one token. Complex or rare words are broken into multiple tokens. Think of the word unbelievable, which is broken down into unbelievable, showing 3 tokens. As a rule of thumb, we can say one token equals 3/4 words. Or the other way around, roughly one word equals 4/3 tokens. OpenAI has a free page where you can enter your sentence and see how many tokens it is in various AI models. Use this link. Let's try this sentence. My name is Mehdi. It is 4 words, but is counted as 5 tokens. Up to now, you have got familiar with token. Let's see how your usage cost is calculated. For each request that you enter into the generative AI application like ChatGPT or send to an AI model API, there is a cost for your input based on the number of tokens. On the other hand, there is a cost for the output as well that the AI system generates. They are usually set with 1 million tokens. See this table comparing the input and output costs of various AI models. Usually, the output cost is higher than the input cost. Let's see the calculation of an example. Imagine you enter this sentence as the input to the generative AI application. What is a typical size of a Scrum team? It is 10 words. If we multiply it by 4/3, it will be roughly 13 tokens. Now imagine the AI system generates this output. It is typically 10 or fewer members. It is 8 words. If we multiply it by 4/3, it will be roughly 10 tokens. Now we have the number of tokens for both input and output. If we multiply them by the input and output cost, you will have the total cost of this communication with the generative AI system. For one sentence of input and a few sentences of output, the cost is almost nothing. But when you have a business usage, let's say Booking.com uses the AI model's APIs to help its customers plan their travels, or Amazon uses it to categorize the thousands of daily received product reviews into positive or negative, then it is a serious cost. Number 5, prompt and prompt engineering. When you want to use generative AI tools, you need to communicate with them through your inputs. A prompt is a text input given to an AI model to guide its response or generate desired output. To write a good prompt, these are the important factors that you should follow. Clearly define the task that you expect the system to do. Provide background information, context. Use a persona, give a role to the AI system. For example, say you are a tour guide, now plan a good tour to Italy. Specify the output format, a table, bullet points, etc. And finally, define the desired style of the output, professional, casual, etc. Just like a team member, an AI tool gives better results when you give clear, structured instructions. Great prompting leads to great output, and weak prompts lead to generic, confusing answers. Good prompts are specific, contextual, and directive. Prompting is like writing a recipe for a robot chef. If you say make dinner, the results will be random. But if you say make a vegetarian pasta with tomato sauce in under 20 minutes for 2 people, the outcome improves dramatically. Prompt engineering is the process of designing effective prompts to generate better and desired responses. One important tip that you should know is that getting quality output is not a one-shot work, but is an incremental process with tuning your prompt, like inspection and adaptation with empiricism. You can't achieve the best result with one iteration. So the motto is iterate, iterate, iterate. Now let's talk about 2 techniques that help you enhance your prompt responses. RAG, Retrieval Augmented Generation, which is an AI technique that enhances large language models by retrieving information from external sources to generate more accurate and context-aware responses. An example is giving your company's HR policy document to a model, then your employees can ask how to use the company parking lots or how to have a work mobile phone. Fine-tuning, which is the further training of a pre-trained AI model on a smaller domain-specific dataset to enhance its performance for a particular domain. Examples are fine-tuning a model for medical or legal domains, as they have their own terminology and way of communication. Number 6, how agilists should see AI, building new mindset. Now I want to give you some hints on how to see AI as agilists. First of all, AI is not supposed to replace you. They are supposed to extend your abilities. Think of AI tools as new colleagues with high knowledge, like PhD. Some are writers, some are analysts, Some are designers. The key to success is knowing what they are good at and assigning them the right jobs. Don't ask your graphic designer to build a financial model. When people hear about AI, they often think of one all-powerful system that can do everything. But the reality is different and actually more helpful. Think of AI tools as if you are hiring new colleagues into your team. Each one has its own strengths and specialties. So AI is not one tool, it's a growing team of digital colleagues. Your job as an agile professional is to know what each one is good at, pick the right one for the task, and learn how to work with them, just like with human teammates. There is another angle to see AI with two factors. Factor one, content type. When we work as knowledge workers, we create some outputs in different content types like text, presentation, code, report, video, etc. Now, with the advent of AI, we see that they can generate the same content types with higher quality. Factor 2, task. As a knowledge worker, we do a variety of tasks from writing code, creating a report, summarizing text, planning action items, recording a marketing video, to presenting an idea, etc. Again, we see that AI is capable of doing these tasks as well with higher quality and faster. If you think a bit deeply, you will see that each AI tool is good at one or a few tasks with a specific content type. For example, GitHub Copilot is an AI tool that specializes in the task of programming with the output content type of code. Or ChatGPT is a great tool to do text-specific tasks like brainstorming ideas, writing text, creating insights, translation, summarization, etc. with various output content types like text, but it's not an option to generate videos. So the takeaway of your new mindset is that when you want to leverage AI, you need to first think of the task that you have in hand and then the output content type that you expect to get as a result. Defining these two factors reveals which AI tool works best for your expectations. And finally, number 7, a practical example. Creating a product vision with AI. Now, as I promised, let me show you a practical example of using AI to create a compelling product vision video. A product without a vision is like a ship without a compass. It might move, but it won't reach the right destination. Have you seen a Scrum team without a product vision? Team members naturally become task-driven people rather than goal-driven ones. A strong product vision aligns teams, inspires stakeholders, and guides decision-making. This sample video is for a double-sided learning platform called MetaLearn, connecting trainers with learners worldwide. Let's watch it.
Being a trainer today is tough. You put your heart into creating and delivering amazing courses, but a lot of challenges are in your way. Working with an endless number of marketing tools, being present on all social media, but still no control on generating new leads. And for learners, it's just as frustrating. Limited learning formats, too many courses and too many trainers, no peer connections, and no AI teacher. Meet MetaLearn, a double-sided learning platform where trainers thrive and learners succeed. Trainers leverage the platform to generate new leads with control through a comprehensive marketing toolkit, earn more, and operate their training business in an easy way that they have never seen. Learners explore any format, find real experts, and connect with peers worldwide. Plus, learn from AI teachers 24/7. The trainer's profile shows their expertise and hard work. No followers, just lifelong learners. Our bold vision is to become the world's largest learning hub in 10 years. MetaLearn, where trainers' happiness meets learners' success.
Now let me explain the steps that I took to create it. For this video, I used these tools: FreePic AI, DeepSeek, 11 Labs, Camtasia. Step 1. Write down all the points that you want to talk about in the vision. Step 2. Ask an LLM tool, DeepSeek here, to create a scenario script for your vision video. Ask it to give you several scenes. Step 3. When you want to create a video, you need to break it down into multiple scenes. Each would be around 5 to 10 seconds. This is because of the limitations of AI generating video tools. For example, for the first scene of this video, I used this instruction. The prompt to create the video of the scene was a cinematic scene where a real human instructor is sitting at a desk, looking overwhelmed, staring at a screen. The narrator's script, energetic yet empathetic. Being a trainer today is tough. You put your heart into creating and delivering amazing courses, but Step 4. Give the scene prompt to an AI generating video tool. For this video, I used FreePic AI. Step 5. Give the narrator text to the 11 Labs AI tool, choose a good voice and download the result. Step 6. Adding all these materials to Camtasia to mix them and create the final result. In Camtasia, I have added background music and some text to scenes. And finally, step 7, rendering the result in Camtasia to create the final video. It was the whole process. Hopefully, you enjoyed the practical example and got a trigger to do it for your organization as well. I'm Hoseini, a certified trainer with Scrum.org and with more than 20 years of experience in the software industry. This free training was the starting point of stepping into the amazing world of AI. If you are a product pro who wants to go further and learn how to leverage AI capabilities in product management, don't miss my upcoming Scrum.org's brand new Professional Scrum Product Owner AI Essentials class. It is a one-day class to fill your AI knowledge gap full of practical exercises forcing you to use AI tools in real use cases of product management. More than that, by joining this official class, you will receive 2 attempts to take the PSTin AI Essentials exam and get the related certificate. Right now, you have a choice. You can continue trying to learn the skill set by watching a massive number of videos on YouTube or spending a lot of time reading blogs, articles, or books, hoping to learn everything on your own. Or spend only one day in the PSTin AI Essentials class under the guidance of the trainer and become an AI-aware product pro. If this sounds like the course you have been looking for, click below and enroll now.